This is a brief demonstration of our BIM-compliant modeling software. BIM is Building Information Modeling, and it is used to improve pre-planning and efficiencies for the construction industry. Normally, these tools are complicated to use, and each trade has to build its own model. Periodically, all trades get together and resolve their issues of clearance and penetrations. This process is costly and best suited to large construction projects. That said, this process will eradicate the rework that commonly adds 5% to the cost of a traditional construction project. The goal of the layout module is to simplify the process and put the modeling in the hands of the people running the work. This will allow the process to be used in smaller projects where the initial design is diagrammatic, two-dimensional drawings from the architect and engineers. In this product, the foreman from every trade can actually build a single model in a web tool and check and resolve penetrations as they are building the model. All this modeling and coordination can happen before anyone has even been to the job site. There is little or no need to have coordination meetings, as everyone is constantly communicating from their separate locations about a common model. The tradesmen have better product knowledge and often prefer to reroute the piping and ducting of systems from the engineer's design. As we like to say here, it is always quicker to do a job the second time, so why not build it virtually the first time? Many users can work in the model at one time, but only one user is allowed to be in a trade at the same time. The model is started by defining the grid planes and elevations of the building. These are displayed as grid lines on the elevations at the intersections of the two. The X and Y grid planes and elevations are defined in the working environment settings. Roof and other off-axis planes can also be set up here. It is also possible to show or hide the model from other trades and select which trade's drawings are displayed. A drawing from each trade can be placed on an elevation. The drawings are scaled to the grid lines. Once you have chosen which grid line you wish to define, you can click until you are satisfied with the result. Then the user simply selects the elevation they wish to put the drawing on, so it can be positioned and scaled to the model. As you can see, this drawing is for the work that has been started above. A full catalog of equipment, we call them box objects, and piping or ducting, we call them line objects, exists in the database. Box objects have connection nodes for each of the trades to connect their line objects. Once the catalog item is selected, the rotations are set. The height is set. Then the elevation is selected, and the box object is placed at the height using Snap to set the location. Here you see the engineer's routing of the piping. We have decided that it may be better to duct this in a different way. We are now going to add some line objects. This will be 10-inch round duct. We have chosen to hard pipe this grill. We have to choose what the duct is going to carry. Normally, we create a new line object for every 2 picks, or we can choose continuous picking. We do not know the exact height here, so we choose Select Height by Node. Again, we choose the elevation. Instead of the 2 elbows and a flex pipe, we have chosen to use 2 elbows and a hard pipe solution to save on material costs. The node changes color to green as you select the connection node that is not at the working height. If you select the node, you are given height options to start the line object. The system has various ways of snapping the line to help you quickly place the line object where you want. Once selected, you are presented with different ways to route your line object. Now we can quickly delete the trim section we no longer need. The box object connection nodes define the direction of flow of the carries. This is displayed as an arrow on the model. This helps the layout module ensure that all systems are complete and helps manage gradients when required. Groups of the objects in the model can be selected and put into work breakdown structures for planning and program management. Here we are going to select all the displayed model components on this floor. We have one for the box object. I will project 2 workers for this, and another for the line objects. I will project 2 workers for this. This will create the 2 work breakdown structures for future assignment. From planning, we can set up our actual assignments. We choose to set the equipment first. We set our crew and select the date we are going to start the work. We have no other assignments that have to be done first. The system can work out the duration from the catalog items and counts or lengths in the work breakdown structure. We can print or fax this assignment directly from this window. Now we can make another assignment. Again, we assign the crew. This time we have another item that we can assign as a predecessor and delay the start of this assignment until after its predecessors. Now you can see that these 2 assignments are ready to go. Traditional construction projects lack the ability to give the journeyman hours targets on every assignment. This again increases efficiencies by removing the large job syndrome, where the journeymen lack the urgency to be efficient. Once the work is completed, the foreman can mark the work as complete in the system. The system will display how many hours have actually been booked as well as the hours assigned. As you can see, the icons in the tree have now changed from red to green, showing they are complete. Others can mark that they have inspected the work after the foreman has marked the assignments as complete. This could be the engineer, the project manager, or anyone who can sign into the system. This changes the icon again. The system can be used to check penetrations within a single trade or between 2 trades. Normally, a user would check for penetrations in their own model, then the structure, and then other trades. Penetrations can be resolved by changing your own model or sending messages to the foreman of the other trade. The messages can actually be sent through the system to take the other foreman directly to the penetration with a request to show how you propose to change their model. The final process that can be achieved with this model is to create a bill of materials. The user must select the types of joints that are proposed to be used and calculate full material lists for each of the work breakdown structures, shown here in separate tabs. These material counts can be used to create purchase orders and set up just-in-time delivery, which will drastically reduce material handling on the job. Material is moved an average of 4 times before it is installed on a traditional construction project. This concludes the presentation of our prototype project. We are currently looking for funding to build a production version of this tool. If you have any questions or interest in this project, please contact Ricky Houtras at the address on the screen.